Tomorrow's the 20th. What happens tomorrow? Is the inauguration of the new president. So be in prayer today, fellas, for our nation, because there's a lot of angst and a lot of, like I said, people being crazy and not being nice. So we need to do our best to lift each other up in love. Thank you, Cash. All right, so as I was saying, here is our warm-up question. What we're going to do today is we're going to make use of all these skills that we've put in practice in the last week or so, and we're going to answer some factoring in the zero product property kind of applications. All right. So first things first, you got to be able to solve a polynomial equation. I got this one on the screen here. Actually, let me zoom in a wee bit so y'all can see it better. So go ahead and solve this one out. And while you're thinking about it, Jackson's going to tell us how many solutions we should end up with on this. Very good. That's our fundamental theorem of algebra, isn't it? A degree 3 equation should have 3 solutions. William Bryan, question. Can you borrow a pencil? I've got a pen you can borrow-ish, I think. It might work. Yeah, it works. Here you go. Now, you guys said about your work. Bless you. I will give you 2 minutos for this problem. So you're going to have to work quickly. And note, by the way, that we're using these zero product properties. So, Luke, your first step should probably be to add what to both sides? Add 4 to both sides. Very good. And then, JT, remember how there's going to be 1, 2, 3, 4 terms. So what technique should I use to factor? Grouping. All right, so you guys should, that should be your hint if you're stuck. All right. I was telling my 8th graders yesterday on our camping trip, I was making some oatmeal, and I poured boiling hot water on my finger, and literally the skin peeled back. It was disgusting. So I'm wearing a pretty pink Band-Aid today. All right, you got about 30 more seconds. Oh, 30 more seconds. Y'all excited, by the way, about Aaron Rodgers, Tom Brady matchup?
Yeah, the old man. Tom Brady just put Drew Brees in retirement. The MVP should be in there.
Poor Drew Brees. Lost his last game. You always want to win your last game of your career, don't you? You think so? I don't know anything about football. I haven't really followed much this year, but they say the Packers are red hot.
Well, the thing is, like...
I didn't ask for the thing. I don't want to know what the thing is. Thank you much. Oh, actually, I do want to know what the thing is. I want to know what the math thing is here. So we said, what, add 4 in group. Quinn, you got 2 good-looking groups for me? All right. So in other words, the first 2 and the last 2. Okay. Now, Cash, what do the first 2 have in common? More than that. Think of GCF. Good. They both have an x squared in them. Justin, what do they have left over when I take out x squared? What kind of 1? Good. So x minus 1. We take out x squared, we get x minus 1. Now, I've got a feeling that I got a feeling that the leftovers on the next one is going to be the same thing, x minus 1. Okay, can you scratch that itch? Can you make that happen? What should you take out, Hogan, to make the next parentheses look just the same? What should you take out, Hogan?
Um,
I want the x to be positive.
oh, negative.
Negative 4. And that means I'm going to have a positive x and a negative 1. Okay, life is good. Savvy? Okay, so it's x squared and negative 4, and then x minus 1. But we can't stop. Joseph Russell, what else can I do? Good. The difference of squares. Difference 2 squares, right? X plus 2. Was that a Pokemon reference? X minus 2. That a boy. Squirtle was one of my favorites.
That's starter.
All right, so x, ooh, them's fighting words. X equals plus or minus 2, or what? 1. Who said that? That a boy, Will Prone. All right, we got our 3 answers. Very good. And you guys had told me we were going to get 3 answers because the the degree of that equation at the top was degree 3. Okay, and so you can plug in those 3 answers and get a true statement. Now that's a very basic run-of-the-mill factor and use the ZPP kind of question. There weren't any curveballs there. Okay, it's very straightforward factoring, grouping, and the difference of 2 squares. But you can ask any question you want to right now, anything at all regarding this problem that you want clarified.
It's just confusing.
Okay, elaborate on that. Which part trips us up?
Like, when we started going down the ladder, you know, like getting problems to that last point is really hard.
It is. It's a process, and here's the hard part about a lot of mathematical processes is that they have, like you mentioned, coming down the ladder. They have step by step, right? And what happens if you miss that first step coming down the ladder? You fall off the ladder, which is not a good thing. Okay, and actually, I heard Luke when you and I, or when the class we were talking a minute ago, and we said, hey, add 4 to both sides. This part right about there is where it seemingly a lot of people will trip up. Not just the add 4 to both sides, but the recognize, oh, I should use this technique to factor and solve. I should use grouping and then execute that, right? So the way that we recognize what to do is by practicing, putting ourselves in those scenarios. All right, so like, check this out. In our text, whoops, this is like where you would go to practice. Okay. Now, do you guys see all the opportunities for kind of making your firm footing there on what to do and when to do it? So like when we are, let's see here. I don't see one that suits like the warm up there, a 4 by terms. But anyway, when you're practicing and you're looking at like a buttload of these problems, that's where you start getting more comfortable with saying, oh, okay, I know what to do right out the gate. Okay, so like I look at, somebody pick one. Y'all just pick a random one. 300? All right, so like 300. Right out the gate, I'm going to FOIL that left-hand side and subtract 8y. Okay, so you want to know without a shadow of a doubt what to do first. Pick another one. 304. All right, add 35, and it looks like 7 goes into all 3 of those numbers. So GCF. Okay, pick one more. 270. There's not a 274. 278. All right, FOIL it out and solve. Actually, no, crap. That one's even easier. They've already factored it out since it said equal to 0. You just set each individual factor equal to 0 and solve. That one's just a ZPP, no factoring involved. But like look at 690. Not 690, 290. Like subtract 625 from both sides, factors the difference of 2 squares. Okay, and on and on and on we go. And you get to where you can recognize pretty quickly what to do. You guys play football? I got some football players in here, right? One of the things that astounds me about football players is recognizing what to do. Like, let's say you're a linebacker. I don't know what the dump a linebacker would have to memorize, but I imagine they look and they see the offensive, what do you call it? Front, thank you. The offensive front, and they recognize, okay, I've studied the film, I've practiced with I'm on defense with my team's scout offense. I recognize what they're about to do is probably, whatever play. And then I adjust them accordingly. So recognizing is so important because the guy, like dummy me, would just be standing out there like, okay, I'll react to what they do. And then I get pancaked because some offensive lineman, just some guard pulls and just smashes me. Okay. Do what?
That's really fun.
No, it's not. But the point is, you don't want to get pancaked by a problem. Okay, you want to be able to recognize what to do and execute quickly. All right. Now, let's look at. I'm gonna throw some word problems at you today. Let's look at the first one right here. It's on your screen, and I've got a little reminder over here. And you don't have to write these down because we've learned these in the first semester. But this is our 5-step word problem solving method. Okay. It is your go-to. It's like your cheat sheet, your backup. If you do football players wear wristbands with like formations and plays and stuff on them? Yeah, maybe like a quarterback would. Okay, this is kind of like where you got a little cheat sheet on your wristband to continue with the football analogy. Okay, and this is going to kind of keep you straight. So understand the question, figure out what they're asking. They're talking about consecutive odd integers. So I'm in consecutive odd integers mode. I got to remember what that means, right? That's a common enough question. You guys have one, I think, on your ACT practice quiz for this week. Has anybody already looked at that? No? It was consecutive integers last week? Okay, maybe that's what I'm thinking of. So we ought to recognize, what does that mean? Okay, I'll let x be the first one, and then either x plus 1 or x plus 2 needs to be the next one, depending on if I'm skipping. If it's odd/even, then I'm going to skip. If it's every integer, then it's just going to be x plus 1, x plus 2, x plus 3, so on and so forth. This one says odd integers, so I'm going to go right ahead and I'm going to say let x be the first one, and then x plus 2 is going to be the next one. Why not x plus 1? Because they're odd, and we skipped over that one. Okay? Those are my two, so checking off my mental list here, done these two things, assign variables. It says the product. Santiago, what does that mean operation-wise? Good. We're going to multiply these two. So I'm going to scoot them closer together, and I'm going to use some parentheses. Oops. Okay. The word is means equals 323. Write an equation. Boom. Now we're in the mode of, okay, we can just solve this just like we did in the warm-ups, just like we've been practicing. Step 4 ought to be, cake at this point. What did we practice doing all those times to use the zero property? I should do what to both sides? You just said it right there, Nick. I should subtract 323. Good. Okay, so you can kind of tell how we're going into our. Don't walk in here late and start distracting people. He's working. You're not. Sit down and get to work. By the way, you got a green check for me?
I'll get that.
Thank you, sir. All right, so why don't we distribute? We get x squared plus 2x and then minus 323 equals 0. Okay, now I'm going to go into factoring mode. 323 is a big number. That's a little bit tough. And if 2 is a relatively small number, then my factor pair is probably going to be pretty close together, pretty close to the end of my list. Remember how we said, fellas, this is where we make a list of factors, like 1 times 323. Okay, 2 times this, 3 times this, 4 times this, so on and so forth. And we get down to the end of our list. Did you say 11 and 13? 17 and 19. Here's the neat thing, what I was going to tell you. I didn't know that. I didn't know 17 and 19 off the top of my head. Where does the bottom of my list occur? Where those two factors are closer together, and therefore the linear coefficient is going to be smaller when I put them together. It occurs near you turn the corner near the square root of the number that you're factoring. So down here where I like to tell you guys, we quote turn the corner. In other words, the end of our list occurs near the square root of our number. So like if I just real quick, if I was stuck on this one, let's say this is a homework question. And real quick, I wanted to drop in the square root of 323. Okay, that's going to be real close to 18. And therefore, my factor pair, I'm going to start hunting around 18. I'm going to try 17. I'm going to try 19. And then boom, I've got my answer. And should it be positive 17 or negative 17? What do y'all think? negative 17, okay? Now, we don't always make that list, do we? We don't always sit there and take the time to make the list out. But we did in this case, so it's going to be 17 and 19. Thank you, Nick. 17 and 19, and you guys said we want a positive 19 and a negative 17. All right, so x equals what? 17. So negative 19. Remember, it's backwards. It's the opposite of what we think there. So there are our two integers. Now, we just solved the equation, but since this is a word problem, we got to make sure we go back and we give them what they want. Give the people what they want, as they say. It says the product of two consecutive odd integers is 323. So let's play this out. Let's see if negative 19 were my first integer, what would the next one be? What kind of 17? Negative 17. Do those two have a product of 323? Yes. So that's my first pair of numbers. All right. What if x was 17? What will my next odd integer be? Nope. Try again. 19. And do those two numbers have a product of 323? Of course they do. All right. So we've got two possible ways to answer this word problem. Is that okay? Is it all right for us to be able to have a word problem that could answer a couple of different ways? You're darn tootin' it would be. You know, think about this as a problem-solving seminar, okay? And you're going to go into the workforce one day, and Cash is going to be working for, you know, so-and-so, and so-and-so is going to give Cash a job. He's going to say, man, I got this problem. Mr. Johnson, fix it for me, okay? Have a solution on my desk by tomorrow morning. And Cash is going to go sit down. He's going to think about it. And if Cash is lucky, he's going to be able to present options to the boss man. He's going to say, hey, not only did I solve your problem, but I'm going to give you two ways to solve your problem, and you pick whichever way you want. And here are the pros of this one and the cons of this one. Here's the pros of that one and the cons of that one. And the boss is going to say, dang, I'm glad I hired you because you can solve problems. Okay? It's okay to have options. All right? Now, what if I snuck this word in here? Y'all pay attention. What if I snuck the word right in here, positive? Now this gets thrown out as an extraneous solution. We talked about extraneous solutions in this class? Extraneous solutions are solutions that we get mathematically, but then in the context of the problem, or they violate something to where we'd have to throw them out. We'd say, I don't need that. That's like an extra anus. Get rid of it. Okay. We talked about that before, right? You can't forget that. We talked about that. Extraneous solutions. So be on the lookout for that. Answer the question. Now, I'm warning you now so that when you are working a word problem and you tell me negative 19 and negative 17 or 17 and 19, and I count off, you don't get your feelings hurt, okay? Because you don't want to include an extraneous solution in your set of answers if that is the case. Questions on example 1? Man, feels like a Monday today, doesn't it?
Yes.
You are kind of pumped. That a boy. What are they serving for lunch today on this fake Monday? You know, we haven't had barbecue in a while. I could go for some barbecue today for lunch.
I know we have
I had barbecue all.
We got barbecue this week sometime?
We have barbecue chicken this week.
Oh, barbecue chicken. Hey, that's kind of the move. I'll take some barbecue chicken. Barbecue chicken in aluminum foil, just enough money for my gas and my oil.
It's really sticky. Out in the bar, what else here is really sticky?
Luke, you would be a complainer about daggone barbecue chicken.
I mean,
You know how good that thing is. It's so good.
All right. You know what else is so good? Example 2. Let's get to it. All right. Bedroom, rectangular bedroom has an area of 117 square feet. Hey, if I just stopped right there, right, and if that first sentence was all you got in this question, there'd be infinitely many ways to set up that bedroom, wouldn't there? Okay. Like for example, you could have a bedroom that's 1 foot by 117, right? Or you could have a bedroom that's 2 feet by 108.5. Not 108.5, excuse me, 58.5. Or you could have a bedroom that's 3 feet by, right? There'd be what kind of system of equations do we call that? Where there's infinitely many solutions, the lines of the graphs will be parallel.
IMS. Independent.
The other way. Dependent, right. That would be a dependent system, okay, by which you could say, hey, there's infinitely many ways to solve this. So in other words, you would need enough information to write another equation. Y'all remember that from first semester? I really am trying to cycle back and sprinkle in some review for you guys along the way. We can't just learn something and then for a week or two and then forget it. So anywho, it says the length of the bedroom is 4 feet more than the width. Okay, so I'm going to stop. And I'm going to say x and x plus 4, something like that. The length is 4 feet more than the width. And then it says it has an area of 117. So what's the, Nick, what's the area formula for rectangular room like this? Good. So we got x plus 4 equals 117. Can you see how we're doing steps 1, 2, 3? We're mowing through these word problem solving steps. And for this one, Ashton, what did I put together to help me make sense of everything? Yeah, a picture. Anytime that we can visualize a word problem, brother, you better do it. Make you a drawing. Start drinking my Kool-Aid, okay? Because I'm a visual guy, and I get these word problems right all the daggum time because I make a picture or make a chart or do whatever. What's your favorite kind of Kool-Aid there, Luke?
I'm a grape or just.
Gosh, dog. You know what? If I had to guess, you rock munching, grape Kool-Aid drinking wrestler, I would have picked you for a grape guy.
No, you didn't let me finish. I like either grape or blue. Like just blue.
Then just choose blue.
I love you so much, Luke. I'm a cherry Kool-Aid man. I like cherry Kool-Aid.
No, the original's like top 3, but you know.
Alfred, what'd you say?
Oh, those hit different.
No. I'm talking like the plastic jar where you scoop it out and you pour it into the pitcher. That's spoken like a true 8-year-old right there. and hey, you don't swish it. You shake it like that.
And he eats ramen and puts like the packet in his mouth.
Oh, lordy. Okay, Luke. I know I'm picking on you about your Kool-Aid, but what should I do first on this equation? Use your brain and think.
You should figure out
You're just giving me an answer you think I want to hear. What would you do first? That's what I want to know.
So, I would put negative 117 on both sides.
Okay, that boy, subtract 117. Hey, can we kill 2 birds with 1 stone, William Bryan? What would you do besides subtract 117 from both sides? Yeah, we want to distribute that x into that parentheses. We're going to get x squared. Finish it up, William Bryan. X squared plus 4x. And then don't forget Luke's. What would you say? Minus 117. That a boy. Equals what, class? 0. That's our goal. We want to use the 0 product property. Okay. Will Perone, what's my next step? Can you guys do that for me? What? You don't think I want to do that, do you? Would you say 13 and 9? All right, so let's do 13 and negative 9. Are we just going to take his word for it? Oh, that sounds good. Those are 2 numbers that subtract to give me 4.
That's what we did with the last.
Touche, my man. Touche. On the last one, I didn't check your arithmetic either. 19 and 17. Who was the one that told that to me on the last one? It was Quinn. my 8th graders that are watching this tomorrow from their homes will probably be like, dude, you've got to be kidding me. They don't have class tomorrow. Let's see here. What is 17 times 19? Okay, so we were straight on that one. Let's check this one. 13 times 9, 117. Okay, kudos. I'm sorry we didn't believe you there, Wilson Webster.
Oh, I never lied. Okay.
All right. So, x equals what? Pay attention here, fellas. Pay attention. Or I smell an extra anus. I smell an extraneous solution. Extraneous. It's like an extra anus. You don't need it. Get rid of it. It stinks.
More anus, not anus.
I know, but it sticks in your head now because I said it that way.
Yeah, are you gonna forget? I don't want.
Probably not. And usually, not to be graphic, but usually I do something like this to help you remember. It's like that. And then my boss walks by and he's like, "What's going on with this person?" No, why is negative 13 an answer, Drake, that I got to throw out? And what's wrong with the negative number here? We had negative numbers in the last one.
Can't be a negative.
Yeah, it's a room. That would be like saying, hey, this room is negative 13 feet wide. No, it's not. That doesn't make any sense. So 9 is a legit answer, but it doesn't answer the question. It says find the length and the width. So it's 9 by 13. So 9 by 13 would be the dimensions of that room. Okay? Quinn?
Is it just a coincidence?
Nope.
that it was 13?
Nope. It is oftentimes going to be like that because of the setup of the problem. Bless you. Because it wasn't a magic method problem to where, so like literally the factors of 117 are the two answers that we got down here, and then one added to the other, or because they were supposed to multiply to equal 117. All right, you want to try? Oh, JT, go ahead.
Why would I not just brute force these and just like go through the factors and
Great question. Great question. If you didn't hear what he said, why can't we just brute force? We totally could.
Is the one that smells really bad?
I don't remember. Again, quit interrupting. The reason we can't brute force it,
I mean, your shit.
for you guys that are watching at home, you didn't just see that. I'll describe for you what happened. Luke got up from his chair, sauntered over here like, he just runs this joint, and got himself some hand sanitizer, and then proceeded to, it looks like he licked it. I don't think he licked it, but he brought it awfully close to his mouth and gave it a little whiff to make sure that it was, the top shelf hand sanitizer. What he would have done with it had it been the smelly kind, I'm not sure because it was already in his hand.
No, it is the smelly.
But there you go. Anyway, JT, we don't want to brute force everything because we'd run out of time. But if you can quickly enough, you can totally do it that way. Now, my job obviously is to teach you guys the problem solving method, so that there will be some times where we can't brute force it.
Will we ever need like a magic man or prediction?
Yeah, definitely. All right, here's our next example. You guys keep me on my toes. I love y'all. Well, yes and no. Hold on, I think I can. I'm going to do both. I'm going to zoom in a little bit here on the screen. There we go. And then I'm going to zoom in a little bit on the projector. There we go. Okay, so that's a little bit better. All right, so I'll read it to you. It says a boat sails in the shape of the right triangle shown below. The hypotenuse will be 17 feet long. The length of one side will be 7 less than the length of the other side. Find the lengths of the sides of the sail. Now, truth be told, I've got this picture on here for your benefit. You won't always have a picture provided. But as I was telling somebody a minute ago, I'm a visual guy. Draw the daggum picture out every time you can. Okay? Now, I've got a little hint over here. And it says, is there any required background knowledge? Okay, what is that required background knowledge? The word hypotenuse makes me think. It is that Pythagorean theorem. Very good. Do we remember our Pythagorean theorem? It says if there's a right triangle whose legs are A and B and whose hypotenuse is C, Then you have the equation a squared plus b squared equals c squared. So in this case, how do I put that to use? I've got x squared plus x minus 7 squared equals 17 squared. Okay, that's 1 leg squared plus 1 leg squared equals a hypotenuse squared. Ashton, make sure you're paying attention. And whoever asked for a magic method example or asked about a magic method example, we have now arrived at one. Okay, or at least I think we have. Now, your job in this case, we just done steps 1, 2, and 3. Your job now is to solve this out. You probably want to FOIL, combine like terms, and get 0 on one side, don't you? Okay, could go ahead and set about doing that. So we got x squared minus 14x plus 49 equals 289. I think 17 squared is 289.
How did you get 14? Wouldn't it just be 49?
Gosh dog it.
Under the square outside of the.
My standing offer to kick you in the gonads will be executed at baseball practice today. Remember, when you have a binomial squared, it's not just square the first term and the last term. That will earn you a swift kick to the gonads. It's FOIL, isn't it? Right? F-O-I-L. So here's the F, here's the L, and then the OI combined together. Williams, that makes sense? I know I'm just busting your chops here, but that's legitimately a mistake that we make all the time, isn't it? Where we're squaring a binomial, we forget. So you got to FOIL that out. And then 17 squared is just 289. Question, Luke?
You might just, where did you get that?
Yeah. It's okay. We FOIL it out. So x minus 7. That's where it comes from. And then when we do the outer, that's negative 7x. We do the inner, that's another negative 7x. So that combines to give us our negative 14x. That's the OI. And you guys, these are important questions. You've got to ask, okay? And so now we're going to combine some like terms down here, and I think we might have a magic method problem. We got 2x squared. We got negative 14x. And then we've got negative 240. Rats, no magic method. Negative 240. The reason we don't have magic method is because everything is divisible by what? Everything is divisible by 2. We subtract 289 from both sides. So everything's divisible by 2, so let's just divide. Okay, whatever I do on the left, I do on the right. Consequently, by the way, it's a great illustration. What's up, Nikolai? When you guys remember last week when we talked about the shape of a quadratic function? What's that shape called? A parabola. Good. And when we're solving an equation, what are we looking for regarding those parabolas? Okay, so you use the word vertex. That's a good vocab word, lowest point or highest point. You used concavity, talking about concave up, concave down. But not the y-intercept, the x-intercept. Remember, when we're solving an equation, we're looking for the roots, aka the solutions, aka the starts with a z, ends with eros. The z, just the zeros. Roots, x-intercept, zeros. These are all synonymous, right? So check this out. What we're literally doing when we're this is you don't have to know this, but this is great for you to understand this. Here's an equation right there, 2x squared minus 14x minus 240. And let's just, I'm just going to make it up. We're going to say it looks like that, okay? And then when you divide everything by 2, all you're doing is you're flattening out that parabola. It's still going to have the same what's. Okay, y'all are just throwing out some math words right there. It's still going to have the same concavity, true. Parabolas don't have a slope per se. Same x-intercepts. In other words, same zeros, same roots, same solutions. It's two different equations that have the same solutions. That's why we're dividing everything by 2, is that we're making it an easier equation to solve. I don't have to use magic method now, making my numbers smaller. And we're not jacking our solutions up. It's still the same solutions, graphically speaking, just one curve is red and one curve is blue. They both cross the x-axis at the same spots. Okay, real good visualization of what we're doing when we're dividing an equation by 2. We're producing an equivalent equation that has the same solution set. Now, I've been beating around the bush. Who's got my 2 factors? This whole daggum time, y'all were supposed to be coming up with factors of 120.
Let's say 18.7.
Hey, don't be a hater. What daggum pair of factors did you come up with?
Oh wait, I came up with something. Watch this, 6 and 9. Yeah.
They need to add up to -7, and that's cute, Luke. Congratulations.
No, that's not right.
6 times 9 does not equal 100.
I said 16.
16 times 9. No, 16 times 9 does not equal 120. Y'all gonna make me dadgum do it. Okay. 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24?
Yeah.
6 times 20, 7, I don't think 7 goes in. 8. 8 and 15? All right, good. So it'll be 8, -15. All right.
I was close.
Well, good thing we weren't playing horseshoes then. X minus 15.
Wait, is there a reason you didn't put the parentheses into 2?
Say that again.
Like, after we divided everything on the left side by 2, is there a reason that you put parentheses into 2?
Oh, man, what a great question, William Kreitz. Yes. I love great questions. All right, so what William's asking about is he's saying right there, hey, Coach, you factored out a GCF. And I know from experience, you've told me before, don't throw the baby out with the bathwater, right? Are we on advisory schedule today, by the way? Y'all know?
You're gonna have to find that out too.
It's Tuesday. We shall see. I got 4 minutes, maybe 5. All right, so time and time again, I've said, don't throw the baby out with the bathwater. Okay, I'll play that game. We'll leave the 2 in there. Okay, this is awesome. Great question. So we factored out the 2 as a GCF. We won't divide both sides by it, but we factored the trinomial. Okay, so the zero product property. Remember my little illustration with like my hands, and I'm like, hey, if you're multiplying 2 things and they equal 0. Well, in this case, imagine I got 3 hands. 1, 2, 3. All 3 hands multiply together. The numbers 1, 2, 3 to equal 0. Then at least one of them has to equal 0. And so you can set each individual factor equal to 0. They're separated by the words or. So x equals 15, or over here, x equals -8. All right. Now you tell me, does anything look goofy there?
Yeah, there's 3 of them get the highest degrees too.
2 doesn't equal 0. Okay. And so that's why, William, great question. That's why I'm free to divide both sides by that 2, because I'm not losing an answer. If this GCF had been a variable, had been like x or something, then the original equation would have been 1 degree higher, and therefore it would have had one more solution. So suffice it to say, and I would write this down if I were you, that you can always divide away a constant GCF. You can get rid of it, throw it out. It's not the baby, it's the bathwater. Okay? But if you have a variable GCF, if you got a GCF with a variable in it, brother, don't throw that away. Okay? What's up, Eli?
Hey, Coach. Happy Monday.
You too, bro.
Tuesday.
All right. Now, so we've solved the equation, but we haven't answered any question yet. The question said, find the lengths of the sides of this sail. Can y'all spot the extraneous solution? -8 is not the length of a sail. Can't have it, don't want it, can't use it. Okay, but 15 looks pretty daggum good. So this sail is 15 by 8 by 17. Okay? 15 works out, -8's my extraneous solution. And then again, it's a coincidence that, it's not a coincidence that -15 and -8 and +15, and we got 8 and 15, again, because it wasn't a magic method example. Okay? All right. Hey, I'm going to stop our lesson right there. You guys did a great job today. Ryan, I'm going to cut you loose on lines. Thank you very much, and love Jesus in our hearts.
Forever.
All right. Pardon me?